Assalamualaikum and good morning everyone.
Waalaikumsalam, good morning Doctor.
Can you guys hear me?
Yes. Hello.
Saya tak dengar suara lah sekejap. Hello?
Hello.
Okay, boleh dengar ke?
Dengar Doktor.
Alright. Okay. Okay, Assalamualaikum and good morning everyone. Kita mulakan dengan Al-Fatihah. Okay, sebelum kita mulakan ni, kita nak maklumlah ada seorang pensyarah matematik. Saya tak pasti sama ada you all ada pernah diajar oleh beliau ataupun tidak, Encik Aziz Samsud. Dah dengar tak nama dia?
Tak pernah dengar Doktor.
Encik Aziz Samsud, dia pass away this morning. So itulah, kita sedekahkan Fatihah lah untuk dia. Sekarang ni tengah diuruskan jenazahnya di Masjid Shah Alam. Okay, alright. Untuk kelas kita for our class today, before we proceed to a new topic, I'm going to show you on an application known as GeoGebra. Have you come across this application before? Pernah guna tak GeoGebra sebelum ni?
Tak pernah Doktor.
Tak pernah, okay. GeoGebra ni dia free dia software, matematik software yang free. Dia sangat simple and you all boleh explore sendirilah. Ini saya tunjukkan sedikit video ni, link ni pun saya dah share dekat dekat Google Classroom, right? If later you have you may want to go through it again at your own time lah ya. Okay, so yang ini gunanya adalah untuk satu lagi apa orang kata buat nak sketch the graph, right? Because kalau untuk tajuk yang application ni ada banyak suruh kita sketch graph, so you can actually apply this GeoGebra to sketch the graph. Okay, so untuk minggu hadapan, minggu 13 ni, saya akan bagi satu assignment I want you to get into groups, group of 3. You all boleh cari member sendiri, nanti boleh letak dalam senarai nama dalam kumpulan tu. Dalam kita punya group tu, satu kumpulan 3 orang. Okay, so untuk buat projek lah, projek ni adalah chapter 5 and above, chapter 5, chapter 6. Topik 5, topik 6, topik 6 termasuklah topik 7, tak ada topik 7 sampai topik 6. Okay, on the application of the higher order or the second order differential equation, right? Okay, you may want to use this GeoGebra to help you out in sketching the graph. Okay, right, so I'm going to show you this YouTube video. So maybe you boleh tengok lah dia macam mana cara dia sketch, buat sketching ataupun apa-apalah yang dia tunjuk nanti tu Okay, alright. Sekejap ni ramai lagi yang tak masuk. Sekejap, mana pergi? Alamak.
Functions. So right here, let me open this. This is the default window that I set up earlier. And we can just go directly to input. I can type in either y is equal to sine x, or maybe if you like f of x is equal to sine x. Both of them
Sekejap saya mula daripada awal sekejap.
Hi, I wanted to show you how we can use GeoGebra to graph trig functions. So right here, let me open this. This is the default window that I set up earlier. And we can just go directly to input. I can type in either y is equal to sine x, or maybe if you like f of x is equal to sine x. Both of them are the same. So if you just type that in, you get the usual sine curve. And this right here, the little f, represents the name of the function that we have. Anyways, let me just change this to make this prettier, so to make us happier. Double click on this, object property, and I'm going to change the, well, I think I'll just keep the color the same. But then let me just check that off. Okay, so I don't want to label. I will keep the color in black. And for the style, let me make the line, the curve thicker. So let's say 7. And notice that you can also change the curve to like dashed lines right here if you would like. But then it doesn't make sense in this situation. So this is the sine function. If you go to text yourself, you can enter your own text. So click on this, f of x, and make sure you select LaTeX formula so you can get a nice like a map print for the equations. F of x equals to sine x, or maybe a parenthesis sine of x, like that. Okay, so this is our usual sine function curve. But then the problem is that, as you know, this is like sine of 0, which is 0. This is what? This is like 3 point something. As you know, this will be pi, 3.14, right? But I want to show that on the graph paper. This is how you do it. Right-click and go to Graphics. Go to X-axis, and then go to Distance. Instead of 1, you can select either pi, and you see the change right here, or pi over 2. And it's going to go up by pi over 2 every time. If you change this to pi over 4, it's going to show you like this, but it won't show you the pi over 4, like the numbers right here, okay? So let me just keep it for pi over 2, like this. So this is it. And if you would like, of course, you can go to the function right here. I don't want to graph sine x, I want to graph sine of 2x. What you do is just double click on this, and then just insert 2 right here. And that will give you sine of 2x. In that case, make sure you also change your text right here as well. This is now sine of 2x. And once again, by doing the text box right here, you get to move the text box anywhere on the graph paper that you would like. Okay, this is pretty much it. But usually we want to see more periods of the sine curve, right? So usually what I would like to do is I would like to make this longer horizontally, and perhaps make this like a shorter. I mean like a shorter. And then let's say the boundary is like a 2 point something up and down like this. So you see a nice sine wave right here. And you can also do a derivative on this, of course. This is function, the name of the function is f of x, so you can just type in f prime of x, and it's going to compute the derivative for you. Derivative of sine 2x. Don't forget the chain rule. You get 2 cosine 2x, right? And just show you the graph right here already. Well, maybe you don't want a derivative. Then you can just go right here. You can click this off, and it won't show the derivative for that. So let me click on the select button right here. I'm going to choose this, move the name to the upper right corner like this. And then we have it. This is the graph for sine 2x. Let me save the picture. Let me save the GeoGebra file first. So click on File and Save. And this is sine 2x. And you should have a folder of all your GeoGebra collection, because it will be better for you for the long run. Save, and now we'd like to go to File and export this to a picture. Save the picture. I'm just going to call this is sine 2x. Open my Word document, and I'm going to insert a photo from File. And there we have it. This is the graph on sine of 2x, and you can put this on Microsoft Word, and you can add your own notes, right here. And once you're on Microsoft Word, I will let you do whatever you want from there. This is it.
Okay, Ya, boleh ikut tak tadi tu?
Bolehlah kot sikit
Nanti
doktor.
you boleh explore sendiri simple je tu. You just type GeoGebra, apa nama ni, geogebra.com tu, nanti dia akan dia akan keluar lah dia punya YouTube dan sebagainya lah. That would be your task next task is to to discover or explore the the GeoGebra, and it's very useful particularly when you want to sketch the diagram, sketch the graph, or you boleh buat untuk 2-dimensional space, 3-dimensional space pun boleh. Alright, you are now taking MET 491 kan? Calculus 3.
Yes.
Okay, so you boleh guna GeoGebra untuk sketching bentuk ellipse ke, bentuk paraboloid ke, dan seterusnya, the 3D, especially the 3D punya solid tu kan. You are able to use that GeoGebra untuk, mungkin you all ada buat projek, kan? Calculus 3 ada buat projek kan?
Kena tukar doktor jadi quiz.
Apa dia?
Kena tukar jadi quiz.
Tak ada projek?
Ya dah.
Okay. So saya masa mengajar dulu saya bagi projek lah untuk sketching dan sebagainya lah dengan GeoGebra. Okay, alright. So boleh dia explore your own, right? Tak adalah susah sangat. Dia sangat user friendly. Okay, tapi if you are all familiar with MATLAB ke, Maple ke, boleh je guna mana-mana. Alright. Okay, I leave it to you yang tu, for you to explore on your own. Okay, is that okay?
Boleh doktor.
Right, so what we're going to do today is we like to extend further our discussion on the differential equation, where we have a set of differential equation that form a system ataupun senang cakap a system of linear differential equation. So how are we going to solve if let's say you have two dalam satu sistem tu, that you ada dua differential equation ataupun 3 differential equation, macam mana kita nak selesaikan? Okay, remember that if let's say you have you have a system of three equation yang biasa. Okay, you ada 3 persamaan dan 3 function dan 3 persamaan. You nak selesaikan katakanlah persamaan tersebut dalam sebutan X, Y and Z katakan. You have 3 unknowns. Okay, and you would like to solve the equation for X, for Y or for Z. Kita katakan apa? Kita selesaikan guna persamaan apa nama dia? Apa teknik dia? Persamaan, menyelesaikan persamaan apa? Serentak kan, betul tak? Persamaan serentak kan, betul? Hello.
Betul.
I kan suara semangat sikit ni, pukul 10 patut dah makan kan. Okay. Alright, persamaan serentak. So bila ada persamaan serentak, so jawapan dia dalam bentuk apa? Dalam bentuk titik kan, betul tak? Betul kan? Dalam bentuk titik kan? Titik X sama dengan apa, Y sama dengan apa, Z sama dengan apa kan? So maknanya titik-titik ni kalau dimasukkan dalam setiap persamaan tu, maknanya persamaan tu akan dipenuhi. Betul? Betul tak? Ini revision lah. If you are having a system of if you are having a system of equation, 3 equation with 3 unknowns. Okay. Now, we would like to extend that concept, that similar concept, into a system of differential equation. So kalau kita ada equation kita dalam bentuk differential equation, macam mana kita nak selesaikan? Okay, so our learning objective for today is, first we would like to rewrite the differential equation using the differential operator, and then we solve the system of linear differential equation using the elimination method, and then formulate the model and solve the system of linear differential equation. Okay, now before we go into detail on how we can solve a system of linear differential equation, let's take a short while. We do some reviewing on the differential operator ni. Okay, so I'm sure you still remember the differential operator. Where do we come across this the word the term differential operator? Kat mana kita jumpa sebelum ni? Kat mana kita jumpa sebelum ni? Hello? Pernah jumpa tak perkataan differential operator? Kat mana kita jumpa?
Annihilator.
Annihilator. When you want to solve the differential equation using the annihilator approach kan? Then we come across this operator many times. So we are not actually learning new things. Okay, so here we'll be using the differential operator to represent the derivative. So where we have D stands for the first derivative with respect to the independent variable. In this case, the independent variable is x, right? And then if you have the D squared, then this one represent the second derivative of something with respect to x. And then if you have D to the power of n, yang ni kita panggil power. Okay, power, D to the power of n. Tapi yang ni kita panggil the derivative, the nth derivative of the function with respect to x. Okay, this differential operator, dia akan transform the differentiable function into another function. And I'm sure you still remember this form, right? General form of nth order differential operator or polynomial operator can be written as L equals to a sub n, right? In terms of x, d to the n plus a sub n minus 1 x, right? In terms of x, d to the n minus 1 and so on, okay? Where L possess a linearity property. Okay, so L ni adalah linear combination of the differential operators, right? So dia adalah dia dan dalam masa yang sama dia memenuhi linearity property. So then we can use this differential operator to to represent or to transform the differential equation into another form, another function. Okay, now if you take a look at this one, the first order linear differential equation. So katakan kita ada a y prime plus cy equals to a function in terms of t. I have a function in terms of t. Okay, so this one can be written as y. Kita boleh tuliskan dalam bentuk apa? We know that y prime is d kan? D represent yang ini kita boleh tuliskan dia sebagai d lah. So we have a d, the first derivative, plus cy. Tengok pen saya ni dia pelik pula ni. Dia tak boleh nak control, dia sengit pula. Sekejap. Okay. Equals to d of t. Okay. So kita boleh tulis dalam bentuk yang ni dy dy maksudnya first derivative of y with respect to t katakan, sebab because the independent variable here is in terms of t. Okay, so by converting into the equation, the differential equation into differential operator form, maknanya we are able to take out the y. Make sure the y diletakkan di belah belakang. Saya tengok dalam masa saya tengah marking, masa saya mark you punya paper on you punya assessment tu, on the differential operator tu, dia pergi letak fungsi kat depan, dia punya differential operator kat belakang. Itu salah memang dia tolak markah. Maknanya apa? Differential operator okay macam ni. Maksudnya y tu, y kena letak belakang. Yang ini kita panggil dalam bracket ni adalah operator. Okay, combination of operators kat sini. Kita letak bahagian sebab dia adalah operator. Fungsi, dia satu fungsi. Fungsi yang bertindak ke atas y. Okay, so this is another way of writing the differential equation in differential operator form. If you are dealing with second order linear differential equation, so you have a y double prime plus b y prime plus cy equals to d of t. Alright, so here you have a d squared plus b d plus c, put it in a bracket, y, right, equals to d of t. Okay, alright. Yeah, you all with me?
Yes, doktor.
Ya, yang keluarkan apa kat sini? Y ni kita letakkan kat belakang. Ini sebenarnya kita tuliskan macam mana, hopefully tak ada masalah. Dan jangan ada operator tapi Y yang tak ada, tak boleh juga. Ini maksud dia A you differentiate the y twice, right? And then you have b dy, right, plus cy equals to g of t. Okay, semua ada y kan? You factor out kat benda ni. Okay, put the y at the back. Macam tu. Okay, alright. Okay, are you all with me? Boleh? Faham? Nota ni saya dah letakkan dalam Google Classroom. Boleh je refer dekat Google Classroom. You can download the notes from the Google Classroom. Okay, so the next thing is, okay, this is an example, okay, just to recall on what we have done before. If you have a d, an operator d act upon x cubed, so this is equivalent to taking the first derivative of the x cubed with respect to x. So kita akan dapat apa ni? 3x kuasa 2. Okay, I think the first one is quite clear cut. The first one is clear cut. Okay, and then the second one also, you are taking the first derivative of the sine 3x. Maksudnya apa? You differentiate the sine 3x, differentiatekan sine dulu dapat cos. So you have cos 3x and then you differentiate the argument of the sine with respect to x, ada 3. That's why you have 3 cos 3x. Okay, alright. And then kalau yang ini you are taking the derivative of this particular function. Nampak tak dia ada dua function? Yang ini adalah fungsi yang pertama. Okay, the one in the bracket is the second function. So you are taking okay, you biarkan e to the 2x and then you differentiate apa nama ni, the one in the bracket ni, cos 4t plus sine 4t, and then plus you just write this one as it is, right? We don't do anything to the cos 4t. And product rule you all hopefully ingat lagi lah, tapi dalam ingat tu pun lupa juga, right? So you taking the derivative this time around, we taking the, sorry, this one should be t bukan x. E to the power of 2t. Okay, so that's why you dapat apa kat sini, dia punya dia punya ni, you akan dapat e to the power of 2t, and then differentiating the cos 4t dapat negative 4 sine 4t, right, plus 4 cos 4t, okay, and then plus 2e to the power of 2t, and then you have cos 4t plus sine 4t. Macam tu, okay. And then you boleh gabungkan lah sine dengan sine kat sini, boleh gabungkan dia punya yang kat depan ni. Dan ni dia boleh gabung, you end up getting this one, right? End up getting this one. Okay, so this is how we perform the differential operator, right, on a function. Okay, hopefully you still remember. Kita dah discuss ni in detail previously. Okay, so I shall move to the next slide. The next slide is another example where we would like to write the differential equation in terms of differential operator. Okay, saya dah tuliskan di sini dia punya jawapan dia. So if let's say you have y prime plus 2y equals to 3x minus 6, right? So this one is equivalent to taking the first derivative of y plus 2y, okay? Dan nampak tak ada y kat sini, you boleh gabungkan. Saya letakkan y ni belakang operator mesti kat depan. Saya ingatkan banyak kali ni ada juga student yang pergi tulis macam ni. Oh, ada dua-dua ada y, letak macam ni, lepas tu d plus 2. Ni salah secara matematik ni salah tulis tu. Nak baca macam mana ni? Y ni ke atas D plus 2 macam tu. Tak. It should be the operator ni bertindak ke atas Y. Okay. Alright, so make sure you write it clearly and correctly. Okay, now the second one, you have a second order differential equation You have three second derivative of y with respect to x lah kan. And you have minus 5 dy plus 4y equals to 4e to dx plus sin x. Okay, again, all the terms here contains y. You take out the y, I put it at the back kat sini, and then put everything in a bracket. In terms of the differential operator. That is one special thing about the differential operator. Kalau derivative, notation derivative yang biasa tak boleh buat macam ni. Okay, differential operator boleh buat macam ni. Jadi boleh keluarkan, boleh faktorkan dan keluarkan y. Okay, again, y duduk di belakang bukan di depan. Okay, so sama juga dengan yang ini, C, you have second derivative in terms of x ni. So you have second derivative of d squared y, d squared x, sorry, plus 3dx plus 7. I take out dx, put it at the back, alright. And you have this form, okay, of differential equation. Okay, right, boleh faham? Razik, okay Razik? Okay, so here you have the sum of the derivative, right? You have x prime plus y prime. Okay, sama juga dengan dx plus dy, and then equals to negative 4x plus 2y equals plus e to the power of negative t. Okay, macam biasalah so yang ni pun macam tu juga, boleh faktorkan, nampak yang ini ada x, ni dua-dua ni ada x. Kalau macam ni pun nak faktorkan pun boleh, bawa benda ni ke depan pun boleh. Cara lain nak tulis pun kita boleh juga kalau kita nak simplifykan x dengan x. So have dx, alright, plus 4x, okay, plus dy minus 2y equals to e to the power of negative t. Okay, you nak tuliskan dia, tak cukup tempat lah pula. Okay, d plus 4, okay, x kat belakang ni, right, plus d minus 2, and then y, right, equals to e to the power negative t. Yang ni pun boleh juga nak faktorkan, nak gabungkan dia punya x dengan x, y dengan y. Okay, so here you have, you combine the x double prime plus 2x prime, you end up getting this term, right, and then you have plus y double prime, ataupun equivalent dia adalah d squared y, equals to x plus 3y. Yang ni kalau nak gabungkan pun boleh. Macam nak gabungkan jadi apa? Jadi apa kat sini? Macam tu, boleh tak? Okay, boleh tak?
Boleh.
Right, so boleh je gabung. Itu sukalah. Okay, alright. So ada soalan nak tanya? Shall we proceed? Boleh proceed ni saya go very slow ni very slow. Siapa yang tak faham boleh tanya. Ni ramai yang tak datang ni lagi ni. Saya tengok familiar name saya yang tak datang. Lepas ni saya kena hantar surat tunjuk sebab kat you all. Surat tata tertib saya ada rekod dia siapa tak datang ni, saya akan hantar. Nama-nama yang tak asyik tak datang je, saya akan hantar. Saya tengok result pun macam tak berapa nak perform. Okay, alright. Ni nak bebel sekejap lah ya. You are all big enough dah dapat peluang masuk UiTM tu, make full use of the time. Okay, ada ramai nak masuk UiTM tapi tak dapat masuk. Okay, you all dah masuk, dah ada dalam ni. Kata strive lah work hard and work smart. Okay, try as much, jangan main take things for granted kan, lepak-lepak, masa apa orang kata, masa tu lah nak tidur ke apa benda ke kan. Okay, so ambil peluang yang ada, masa datang peluang yang datang sekali je. Okay, alright, so kalau rasa-rasa macam tak faham, I welcome you all, PM saya personally, boleh tanya, nak set orang kata nak tutorial apa orang kata personal coaching pun saya insyaAllah saya boleh entertain lah benda tu kan. Bagi tahu je, okay, jangan segan-segan. Okay, so hopefully saya boleh bantu mana-mana yang patut lah kan. Yang itu you all kena ada inisiatif sendirilah Saya tak nak panggil-panggil siapa-siapa, awak kena buat macam ni, awak kena buat macam ni. No, I think you are all responsible for your own ni. Dah besar masing-masing, dah budak universiti kan, bukan sekolah rendah ke, nak kena piak-piak telinga ke, nak kena tunjuk otan ke kan. Bukan, dah besar-besar. Tapi saya perasan tengok, I don't know lah, mungkin sebab pandemik ke apa ke, dia macam lemau je. Semua benda nak kena suap kan. Nanti bila dah keluar daripada daripada UiTM ni tak reti nak bergerak di atas kaki sendiri, right? Sebab semua benda dah dipermudahkan. So orang kata tak tahu nak menghadapi kesusahan ke, tak boleh nak handle stres. Sebab nanti bila you dah bekerja, dia punya stress level tu dah lain macam So masa ni lah you nak train yourself. Okay, kalau lecturer bagi kerja susah-susah sikit ke, banyak kerja sikit tu, take it positively, cuba handle manage your time wisely. Okay, alright. So ambil peluang ni ambil peluang ni. Alright, itu ingatan saya lah. Saya ni dah macam mak-mak you all lah kan. Nasihat biasa lah macam tu kan. Kalau rasa-rasa boleh diambil, ambil lah. Rasa macam masa tak sesuai, tinggalkan. Okay. Alright. Okay, so we go back to our discussion. So we proceed to the next slide. Alright, so how are we going to solve a system of differential equation, right? A set of differential function xt, yt and zt that satisfy each equation in a system of linear equation over some common interval. Set ini kita panggil dia solution of a system of differential equation. Okay, I did mention kalau kita ada set of equation, persamaan biasa, kita selesaikan guna persamaan serentak, kita akan dapat set titik-titik itu adalah penyelesaiannya, di mana titik-titik ni yang mewakili nilai x, nilai y, nilai z. If you plug into the equation, back into the equation, you akan dapati semua persamaan ni akan dipenuhi. Maknanya titik-titik tersebut adalah penyelesaian bagi sistem tersebut. Okay, but when we deal with a system of differential equation, rather than kita ada persamaan yang biasa ni, kali ni kita ada persamaan dalam bentuk differential equation, ataupun kita kata you have a set of differential equation. So solution dia ada dalam bentuk function. Okay, bukan dalam bentuk titik tetapi dalam bentuk function. So katalah you punya sistem ni ada 3 pembeli ubah, ada x, y, ada z. Okay, ada t contohnya. Okay, t adalah dia punya independent variable. So maknanya bila you selesaikan nanti, you all tak akan dapat titik tetapi you all akan dapat function. Function ni adalah x in terms of t, y in terms of t and z in terms of t. Okay? Alright. How do we go about solving a system of linear differential equation that contains the derivative of dependent variable with respect to a single independent variable? Contohnya macam you ada x, y, z ni, semuanya dinyatakan dalam single independent variable t. Okay, so the first step is, basically there are 4 steps involved. Step yang pertama, you got to rewrite all the equation in terms of differential operator form. Okay, in the form of differential operator. Macam tadilah, you convert dalam bentuk differential operator. Okay, step yang kedua, you need to eliminate one of the unknown function. Unknown function ni dalam bentuk dependent variable. Sama ada ni nak hapuskan x ke, nak hapuskan y ke, ataupun nak hapuskan z ke, bergantunglah, it's up to you. Okay. And then step 3, solve the differential equation that contains the remaining dependent variable using appropriate method. Sama ada nak guna elimination method ataupun nak guna substitution method, kan, terpulang. Sama dengan teknik yang kita gunakan untuk selesaikan differential operator tu. You boleh guna kaedah penghapusan ataupun kaedah penggantian, kan. Okay, so we be using similar technique. And then finally, you solve for the other unknown function by repeating step 2 and step 3. Okay, kalau dia differential system that contains 2 differential equation, jadi senanglah, you hapuskan x, you selesaikan y, ataupun you hapuskan y, you selesaikan x. Okay, kalau ada 3 You kena hapuskan X, you express the remaining function in terms of Y dengan Z. Lepas tu you selesaikanlah Y dengan Z dulu, lepas tu barulah ulang balik sampai habis. Okay. In some cases, step 4 can be shortened by substituting the function obtained in step 3. Maksud dia step 4, step 3 ni, so kalau sekiranya kadang-kadang kita tak perlu guna elimination untuk kedua-dua pembeli ubah yang terlibat. Kita boleh dah dapat satu pembeli ubah, function pembeli ubah tu you masukkan dalam equation yang satu lagi. Itu kaedah substitution. Pun boleh, tak ada masalah. Alright. Okay, yang penting kita dapat selesaikan dia punya system of differential equation ni. Okay. Alright. So this is basically a general procedure solving or finding the solution of a system of ordinary differential equation. Okay, now we take a look at this example. Okay, I've already worked out the solution, but I'm going to saya nak insert. Kita start daripada saya nak letak kat mana dia dah sudah kan dia ni. I would like to start from scratch so that we know what's going on. I just copy the mana tadi soalan ni, dah hilang tadi. Saya nak copy soalan je. Okay, jap. Okay, I want to take out blank piece of paper. Alright. Okay, mari kita tengok macam mana kita nak selesaikan dia punya hilang. Okay, alright. So this is the example involving two differential equation whereby the differential equation contains two dependent variable x and y, and both the dependent variable x and y can be expressed in terms of the single independent variable t. Okay, and we would like to solve this differential equation by systematic elimination. What does it mean by systematic elimination? Elimination ni, when we come across the word elimination ni, maksud dia either you eliminate the x first and solve for y, or you eliminate the y and followed by the x. Itu kaedah elimination. Okay. Okay, do you have a blank piece of paper with you? Alright, I want you to scratch lah, whatever, scratch, scribble lah apa-apa yang patut ni. Alright, so kita start daripada awal lah. Okay, so untuk yang ini, just to tally dengan solution yang saya dah beri tu, what I did is I solve for y by eliminating the x. Okay, maknanya saya hapuskan x dahulu and then selesaikan untuk y. Alright, kita akan guna kaedah tu, kita hapuskan x dan y. Okay, now this equation is not in differential operator form. So what I want to do first is I convert the equation. So we have dx equals to 4x plus 7y, right? And then the second equation would be dy equals to x minus 2y. Okay, we collect like term. Like term maksud dia macam term yang mengandungi x kita gabungkan. So we have I'm going to do it step by step. Dx minus 4x, alright, minus 7y, right, equals to 0. Okay, and here you have negative x, alright, plus dy plus 2y, right, equals to 0. Okay, so the first equation can be written as d minus 4, right, x minus 7y equals to 0. Okay, and the second equation can be written as negative x plus, put in the coefficient ataupun the differential operator, right? So d plus 2 onto y equals to 0. Ini equation number 1 and this is equation number 2. Are you all with me? Are you all with me?
Yes.
Alright. So apa tadi we would like to eliminate or we eliminate x and then you solve for y, isn't it? Okay, meaning that by looking at the equation, notice that the differential operator acting on the x dengan in the first equation dengan in the second equation tak sama kan? Alright, so what I want to do is from 1, okay, from 1 we have, okay, this is from 1, we have d minus 4 x minus 7y, alright, equals to 0. And then from 2, what we do is we just multiply the negative ni dengan d minus 4. So I simply orang kata apa ni, saya kenakanlah d minus 4 ni ke atas equation number 2. Okay, what we have is, we have negative in bracket d minus 4, right? X, okay, plus d minus 4, put it in a bracket, right? And then you have d plus 2, and then y equals to 0. Okay, are you all with me? Boleh ikut ke, Ismail?
Boleh.
Boleh. Apa saya buat kat sini, Ismail? Saya kenakan d minus 4 ke atas equation number 2, isn't it? All the terms.
Yes.
So I apply the operator d minus 4 onto each term in equation number 2. So you have the negative ni boleh letak kat depan, letak kat belakang. Alright? Okay, boleh letak kat belakang, boleh letak kat depan. Dia punya negative sign. But the x ni mesti belah selepas operator. X1 ni selepas operator. Okay? Alright, so what happened is by applying the differential operator onto equation number 2, notice that the operator that acts onto x are similar, right? Cuma bezanya satu positif, satu negatif, isn't it? So katalah you let this equation number 3 lah okay, so apa saya buat adalah saya buat apa equation number 1 plus equation number 3, isn't it? Why did I take the sum of these two equations? Because we would like to eliminate the term containing x, isn't it? So by doing so, this term will disappear. Okay, this term will apa kata dia vanish lah, because you are taking the sum of the positive term ni dengan negative term. Okay, the remaining is this one. Yang ini tambahkan dengan yang ini. Okay, so if you want to write it as d minus 4, alright, d plus 2, and then y, so you have plus 7y, alright, equals to 0. Okay, this one can be simplified further. So you have d squared plus 2d minus 4d is minus 2d, isn't it? Plus ke minus lepas tu? Hello, kembangkan. Dapat apa ni? Kan, betul tak? Dapat tak?
Dapat, Doktor.
Dapat berapa ni? Macam tu kan?
Yeah.
Okay, so kita boleh faktorkan lah. The new one would be d squared minus 2d minus 1. Minus 1 ke plus 1? Minus 1 lah kan? Betul lah kan? Minus 1 kan? Okay, put in a bracket. Alright, y equals to 0. So notice that there are no more x in the resulting equation ni. There's no term involving the x. So all are in terms of y. Okay, so this is the new equation. Alright, this is the new equation. So let me just double check with the solution. Saya rasa macam okay. Kenapa dia tolak ni tolak? Saya nak double check, takut tersilap. Okay. Kenapa ini tolak? Betul lah ni tolak kan kat sini? You all perasan tak? Hello. Tak perasan? Saya tambahkan.
Perasan.
Ini yang
Suatu
perasan.
biar sikit tadi.
Tengok tapi tak ada siapa pun yang ni.
Takut ada tersirat kan.
Tak boleh tersirat, takut kena rotan Okay, so maknanya yang ini sepatutnya apa tu saya macam pelik je ni. Sekejap. Kat mana yang silap? Cuba kira balik semula. Minus kan, minus 7. So minus 8 minus 7 dapat berapa? 12 15. Negatif 15 kan?
Yes.
Betul ke? Macam tu. Okay? Alright, dah betulkan dah? Saya kena double check ni. Kadang-kadang kita tak perasan ya. So kita dapat macam ni. Betul lah. Alright. Okay. So kita akan dapat. Okay, tolong ingat dia punya equation ni. D squared minus 2D minus 15. Alright. So you have D squared minus 2D minus 15. Kan macam ni kan? You have a homogeneous differential equation. What do we do next? You transform into a characteristic equation. The corresponding characteristic equation happens to be what? K squared minus 2K minus 15 equals to 0. No more y kat situ. Okay, can we factor out? Can we factor out the polynomial ni? What do you think? Boleh ke? Dapat tak? K kali K kuasa 2, tolak 5K tambah 3K jadi tolak 2K and then plus K plus 3 multiplied by negative 5, we have negative 15. Okay, so here we have two values of K. K happens to be negative 1 or K equals to what? K equals to 5, right? There are two values of K, meaning that you have what? Function that relates to real and distinct roots, betul tak?
Madam, kenapa negative 1?
Negative 5?
Negative.
Apa? Oh, negative 1. Negative 3. Tengok tu. Inilah kan. Okay, betul. Thank you. Thank you, Afika. Alright. Negative 3 dengan apa? 5. Ini tak ada tersirat ni. Kalau salah, kena sebut salah. Elok you remind me. Okay, alright. So this one should be apa? Negative 3 kan? Alright. Okay, what do you think the equation looks like under the function? So therefore here, the y can be written as what? Anyone? Is this a Cauchy-Euler differential equation? Is this one a Cauchy-Euler differential equation? Ismail, what do you think?
Not sure.
I'm not sure, bukan. This is not Cauchy-Euler. This is a typical differential equation with constant coefficient, alright? So in that case, since the roots to the corresponding characteristic equation happens to be real and distinct root, nampak tak? The roots are real and distinct. So what can you say about the solution function then? So you have what? C1 e to the power of negative 3t plus C2 e to the power of 5t. Are you all with me?
Yes.
Alright, so we managed to solve for y. Okay, so just to double check with the solution that we have. So here you have C1 e to the power negative 3t plus C2 e to the power. So managed to come up with the solution representing the solution, one of the solution function, particularly the y in terms of t. Okay, so we are done with the first function. We have another one which is the x. You can actually repeat the whole process. You're repeating the whole process, but this time around, rather than eliminating the x, we would like to eliminate the x, and then you solve for. You rather than eliminating the x, solve for y. This time around, you eliminate the y and you solve for x. Okay. Let me just show you the process kat sini, right? So this one is what we have done just now. Okay, the next step is you solve for x by eliminating the y. Okay, now I want you to focus on this working kat sini. Alright, so nampak tak saya dah highlightkan the operator with red coloured ni font ni. Alright, so what we do is the original equation is d minus 4x minus 7x, right? Saya nak tunjuk kat sini d minus 4x minus 7y kat sini. Okay, so this is the original equation. Now, we would like to eliminate the y and we want to solve for x, meaning that we would like this information to retain. Kita nak eliminate yang ini. The term containing the y ni is the one that we are interested in eliminating. Okay, so equation yang pertama dia tak ada d plus 2. But equation yang kedua dia tak ada 7. So what we do is nak bagi dia sama, we need to perform this process. Okay, alright. So kita buat apa? Kita buat adalah disebabkan kekurangan tersebut tu, saya telah apply the operator d plus 2 onto all the terms of the original equation. Saya apply ke atas x dan ke atas kat sini ni, right? Yang ini sepatutnya adalah y kot sekejap y kan, ada tersilap kat sini. This one should be y. Macam mana boleh tak perasan? Ini adalah y. Okay, alright. Okay, so we have equation number 4. Okay, equation number 2. Kalau perhatikan number 2 ni, dia tak ada 7 dekat sini kan. So saya darabkan 7 dekat semua sebutan. Okay, so saya merahkan 7 multiply by, kalau constant kita kata multiply. Kalau operator kita kata apply the operator d plus 2 onto equation number 1. Tapi kalau skala begini, so we are actually multiplying the equation number 2 dengan 7. Okay, itu cara kita explain. You are all mathematics students. You kena betul-betul lah bila nak explain tu, make sure you use the right term, okay, in explaining the process. Okay, so apa yang saya buat adalah saya darabkan ke semua sebutan yang asal tu, okay, dengan 7. So have negative x dengan darabkan 7 dan d plus 2y ni multiply with 7. So hasilnya nampak tak? Yang mengandungi term that contains y ada di dalam kedua-dua equation ni. So again, because of the difference in terms of the sign, satu positif, satu negatif, I take the sum of the two. So equation number 4, you add up with equation number 5. So as a result, this term will be eliminated. Okay, the remaining term would be d plus 2 d minus 4x plus negative 7x. So you have this one. let it equal to 0 because the right hand side are all 0. Okay, simplifying, ini expand macam tadi, so it turns out that macam sama dengan yang kita dapat sebelum ni, but this time around the variable are x, in terms of x, bukan in terms of y. Okay, are you all with me? Yang ni in terms of x, in terms of y, ini this one is in terms of y, but this one is in terms of x. Okay, and converting the equation into the corresponding characteristic equation, we have this equation sama juga macam tadi, and the value of k happens to be the same, which are -3 or 5, and again we have real and distinct root to the corresponding characteristic equation. So as a result, we have x in terms of t equals to C3 e to the power -3t plus C4 e to the power 5t. Okay, nampak tak? Yang tadi, the first time tadi, saya gunakan parameter C1 dengan C2 kan? Betul tak? Betul tak? Yang ni saya gunakan, dia ada sebab ya, bukan main suka-suka hati je. Okay, dapat C1 dengan C2. Okay, so next one, you are not allowed to use the same parameter. Make sure you use other parameter, C3 dengan C4. Walaupun term dia adalah sama, but you must make sure you use different parameter. Okay, now, nampak tak? Yang tadi, previously we have this one, right? Previously we have y in terms of t. Okay, you have this term where the parameters are in terms of C1 and C2. Okay, and just now you managed to solve for the x, and the parameter is in terms of C3 dengan C4. Okay, now kita tak boleh nak maintain dalam bentuk begini. Kita kena cari dia punya equivalent. You must find the equivalence of the C3 in terms of C1 or C2. Similarly, C4 need to be expressed in terms of C1 and C2. Okay, what you do is dia kata kat sini substitute this function x of t dengan function in terms of t ni tadi dalam equation number 2. Okay, cuba kita tengok dekat equation number 2, the original function. Okay, equation number 2 tadi, nampak equation number 2. Okay, actually kan mana-mana equation boleh guna. Saya saja pilih equation number 2, dapat equation number 2, so gantikan the function x tadi in terms of t, and then y gantikan dengan function in terms of y tadi tu. Alright, so what we did is, so you have this one is apa ni? This is the derivative of, okay, cuba tengok dia punya equation dia apa tadi. Equation number 2 tadi, kita tuliskan balik equation number 2. Negative x, ambil yang ni pun boleh lah dy dt. Ni, kita ambil yang ni. Senangnya kan, saya rasa saya buat je balik semula. Okay, yang ni kita dah buat yang ni tadi kan. Okay, sekarang kita buat eliminating y and I solve for x. Okay, saya perform teknik yang sama tadi kan. Saya dapat apa tadi? Saya dah tunjukkan kaedah dia macam mana. You selesaikan, you ulang balik proses yang sama. So you should be getting x of t equals to what tadi? C3 e to the power -3t kan? Saya start daripada sini lah senang. Okay, so kita dah dapat yang ini, kita dah dapat yang ni. Okay, I cut the story short dapat solution y dengan x ni. Okay, so sekarang ni we want the parameter C1 dengan C2 ni, dia kalau ini pun nak dalam sebutan C1 and C2 juga supaya dia tak ada sampai 4 macam ni. But you must try to find the equivalent of the C3 and C4 in terms of C1 and C2. Okay. So what we do is kita substitute ini equation, katalah kita sebut equation 1 lah, ini 2 macam tu. Okay, substitute the 1 and the 2 into, katalah pilih je lah yang mana-mana tadi. Katalah saya pilih equation yang pertama, equation yang kedua tadi. Cuba ingat benda ni, dy dt. Okay, dy dt x minus 2y, dy dt Equals to what? X minus 2y, isn't it? Okay, so dy dt is what? You take the first derivative of y with respect to t kan? Maknanya you differentiate this one with respect to t. Okay, now can someone please tell me what do we get here? Negative 3 c1 e to the power of negative 3t and then plus. Alright, how about the expression on the right hand side? C3. Betul tak? Kan? Lepas tu tolak. Tolak berapa? 2y kan? Y sama dengan apa? C1. C1. Okay, kalau kita terus yang ni dia akan jadi tolak jugalah kan? Tolak 2 C2, betul kan? Okay, now so sekarang ni kalau you perhatikan dekat sini tengok dia punya yang sama ni, E kuasa negatif 3T. Cuba tengok E kuasa negatif 3T. Tengok koefisien dia apa? Koefisien dia negatif 3 C1 lagi. Scan. Ini kan? Ini kan? Betul tak? Alright, so equals to C3 plus 2C1, betul? Are you all with me? Apa saya buat ni? Saya compare the coefficient, right? So the term containing e to the power of negative 3t. Yang ni saya ambil dia punya coefficient dia adalah pun negatif 3 C1 on the left, on the right kita ada C3 dengan C3 plus apa?
It is negative.
Oh negatif alright, ada negatif kat sini, terperasan dekat atas. Okay, betul. Alright, so kita tolakkan. Tolak. Okay, lepas tu gabungkan. Okay, cuba gabungkan, dapat apa? C3 sama dengan berapa? Negative C1. Okay, dah dapat dah. Okay, how about the term containing e to the power of 5t? We compare the corresponding coefficient. So we have 5C2 equals to, how about the expression on the right hand side? Any term that are related? C4 minus 2C2. Okay, now we solve C4 in terms of C2 then. C4 dapat apa? 7, isn't it? 7C2, isn't it?
Yes.
Alright. Okay. Alright. So maknanya kita boleh nyatakan we can express our function, the solution function can be expressed in terms of what? So first we have x. X of t equals to kalau nak gunakan x dululah, y of t. Y of t dapat C1 e to the power negative 3t plus C2 e to the power of 5t kan tadi, betul tak? Just to double check on the function that we have managed to solve tadi, yang ini. Okay, sekarang ni the xt is in terms of the parameter C3 and C4, right? And we managed to find the equivalence of the C3 in terms of C1. So C3 is negative C1. So meaning that the x can be written as negative C1 ke tadi? Betul tak? C3 tadi? Alright. C4 sama dengan apa? 7 C2. So here you have plus 7 C2 e to the power of 5t. Okay, so these are the solution functions for the system of differential equation that contains the variable x and y. Okay, are you all with me? Alright, so this is how we go about solving the system of differential equation. So cumanya bila guna kaedah begini, you kena dapatkan the equivalent of the parameter. That's why in the first place, make sure you don't use the same parameter for the terms ni. Jangan excited lah guna C1, C2, semua nak C1, C2, tak boleh. Okay, alright. So the general solution of the system of differential. Kenapa kita panggil general solution? Because we don't know what the specific value of the C1 and C2. Okay, so macam mana kita nak dapatkan C1 and C2 depending on the system tu. If the system are subject to some initial condition, right, then you can use that particular initial condition to solve for the parameter C1 and C2. Okay, kalau tak ada diberikan, alright, if the equation does not involve any initial condition, then we leave the answer in this form, right? So we have a general solution to the system of differential equation. Okay, boleh faham? Boleh, Razik je faham, yang lain macam mana?
Boleh.
Boleh. Aisyah, okay Aisyah? Aisyah, okay ke?
Yep, okay madam.
Slow je suara Aisyah ni. Okay, Roslina, macam mana? Okay, boleh. Roslina ada?
Okay, doktor.
Dengar suara Roslina ni. Kena sebut pun nak cakap. Okay, alright. So we are done with the first example. You may want to go through again this example to understand further. Alright. Okay, alright. And yang tadi saya cerita kan, guna pertama tadi elimination method, meaning that you need to perform 2 kali lah repeating the same process. One you solve for X and the other one is solving for Y. But you have an alternative method. You boleh, rather than performing the same procedure again, right? You can actually perform the elimination method once, but the other variable can be solved by using substitution pun boleh, tak ada masalah. Okay, cara ini akan dia akan kata shorten the process tu. Okay, alright, but it's up to you mana satu you lebih suka, but I would prefer the alternative way lah. Okay, now this is the original equation being expressed in terms of differential operator, right? Equation number 1, equation number 2 macam kita buat tadi. Okay, and this one is I eliminate the X, eliminating the X, and we would like to solve for Y. Okay, so we have done this process earlier. Kan kita dah dapat dia punya homogeneous differential equation in terms of differential operator form, right? And then you transform into the corresponding characteristic equation. Yang ni you factor out and it turns out that the K is real and distinct kan. So this is the solution that you have. Okay, rather than repeating the same process, right? Kita pegang yang ini, dah dapat satu solution, right? Apa yang kita buat adalah you just choose any one of the equation dekat sini. Okay, disebabkan you dah dapat Y. Okay, you dah dapat Y, you boleh selesaikan untuk X. Saya pilih equation number 2. Why did I choose equation number 2? Sebab kita boleh jadikan X sebagai tajuk. You dah dapat Y, you simply perform the 2 multiplied by Y and also the derivative of Y. Sebab kita dah tahu Y ni apa. Kalau you masukkan dekat equation yang pertama, you nak cari X, Y dah tahu, okay settle kat sini, tapi nak X kita tak tahu, lepas tu you nak dapatkan dia punya derivative pula. Jadi macam nak kena perform integration lah pula kan. So senang guna equation yang kedua. Okay, alright. So in this case, what are the information that we need? We need to have Y and we need to have the dy dekat sini, right? Meaning that you need to find the first derivative of Y with respect to T. Okay, so what I do is I simply write the Y as it is, right? And then from the Y, you take the derivative of Y with respect to T, which happens to be negative 3 C1 e to the power of, ni pun ada kesilapan kat sini ni, sepatutnya apa ni, negative 3 kan? Okay, nanti dekat nota nanti awak betulkan Okay, boleh? Alright, betul kan kat sini, ada typo error kat sini. You bezakan yang ni, differentiate this one, dapat benda ni. And then what we do is, kita substitute benda ni dalam equation yang kedua. Nampak tak, equation yang kedua ni, kita boleh tuliskan sebagai apa ni? Kalau you jadikan X sebagai tajuk. X ni sama dengan dy plus 2y kan, betul tak? Betul kan? Saya pindah ni ke sebelah kanan, dia akan jadi X kan. Dia akan D plus 2 bracket Y ni, you boleh expand. Ini sama dengan dy plus 2y. So maknanya kita dah tahu Y kita dah tahu, dy pun kita dah tahu. So apa yang berlaku adalah, so here you have, ni pun ada missing term ni kat sini. Yang ini sepatutnya sama dengan. Saya tak tahu macam mana boleh hilang. Saya tuliskan kat sini. Saya minta you baiki nanti dekat nota. Takut saya PDF kan, saya tak perasan ini. Okay, alright, so kita dapat benda ni, dy is first derivative which is simply this one, right? The negative 3 c1 e to the power negative 3t, alright, plus 5 c2 e to the power 5p, and then plus 2 times y, this is the y. Okay, so nampak tak? Yang ini you boleh gabungkan the coefficient of the e to the power negative 3x ni, 3t sorry, you boleh gabungkan, dia akan jadi apa? Negative c1 e to the power of negative 3t. Okay, and then the second term involving the e to the power 5t, you boleh gabungkan dengan second term dekat sini, so you have 7c2 e to the power of 5t. Okay, so dapatlah jawapan yang ini. Okay, sama tak dengan yang kita buat tadi? Sama tak? Sama kan? So now it's up to you lah, you nak guna yang mana satu. Dua-dua accepted. So I suppose you would prefer the alternative way, isn't it? Sebab dia pendek dan dia terus dapat tak adalah dapat C1, C2, C3, C4 kan. So dia terus dapat in terms of C1 and C2. Kenapa dia ada dua pun boleh ubah dua parameter? Sebab dia adalah the function involve two variables, right? X dengan Y tu. Okay. Alright, boleh faham? Any questions so far?
No.
Kalau tak ada soalan saya tanya lah ni. Kita nak panggil siapa Ayuni, Siti Nur Ayuni. Ada tak kat sini? Siti Nur Ayuni nak dengar suara lah. Ya, ada soalan.
Tak ada.
Tak ada. Okey, boleh faham.
Faham?
Faham, alhamdulillah. Okey, siapa lagi nak tanya? Kristina ada? Kristina? Boleh faham? Ada soalan nak tanya? Hello, Christina. Okay, ada line problem. Okay, seorang lagi siapa? Zahira. Oh, Mak Serosa. Alright, faham. Okay. Zahira? No Zahira? Zahira boleh dengar ke? Okay. Alright. So this is how we go about solving the system of differential equation. Okay. Yang ini melibatkan first order differential equation. So you may come across cases where the differential equations are of higher order. Okay, yang ini homogeneous dan ini homogeneous. Maknanya the expression on the right hand side is 0. Okay, sometimes you may come across cases where the combination of the equation involve homogeneous as well as the non-homogeneous differential equation. Okay, so I suppose the next example will deal with solving the system of differential equation involving the homogeneous and also the non-homogeneous differential equation. Okay, I've already worked out the solution. right? And then just explain to you the what is on the slide. Okay, nampak tak? Equation ni macam biasa, you transform into equation in terms of differential operator form, right? So here you can combine these two terms. So you have D minus 4 and then X. D adalah first derivative of X tu, right? Combine in dua ni. And then you have D squared Y equals to T minus 3. Okay, and then the second equation would be taking the first derivative of X plus X. Ni you akan dapat D plus 1X, I factor out, and then plus dy equals to 0. Okay, right, now we would like to katalah untuk soalan ni saya nak solve for X and I eliminate the Y. Kalau nak eliminate the Y, nampak tak? Kat sini ada second derivative, right, in the first equation, but the second one only contain first derivative. So what I do is, I didn't do anything to the first one. Okay, the first equation remains the same. Nampak tak? Sama je, tak ada buat apa-apa. Okay, equation yang kedua, I apply the operator D. Saya bukan darab mathematically, it must be correctly apa yang kata spell out kat sini. We are not taking the multiplication of the operator. We are applying the operator D onto equation number 2. So equation number 2 saya apply the operator D. So have D plus 1. Saya merahkan dia punya D ni supaya kita tahulah apa kita buat. Yang ni pun saya merahkan lah. Kenapa saya merahkan dekat sini? Sebab saya telah buat apa kat sini? Saya darabkan kan? Bukan darab. Saya apply D ke atas D kan? Jadi D squared. Dapat macam ni. Okay. Alright. So can I eliminate the term now? How do I eliminate? Notice that the sign are both positive, right? The first equation positive juga. Kat sini pun positive. So saya kena tolak lah. Saya tak boleh tambah. Kalau tambah, dia tak jadi kosong. Okay, saya kena tolak. Sebenarnya equation number 1 ni, saya tolak dan equation number 2, maknanya D minus 4X, tolakkan dengan benda ni, dapat benda ni, right? And then this term disappear, right? Because you have D squared Y minus D squared Y. Okay, and then don't forget the expression on the right hand side. So you have T minus 3, tolakkan kosong, dapat T minus 3. So notice that the resulting equation is a non-homogeneous differential equation. Can we simplify further? Boleh simplify kan? Nampak tak? Kita ada apa? Kita ada apa kat sini? You have D minus 4 and then minus D plus 1. Okay, we take out the operators and put everything in a parenthesis ni, so you have X kat sini. So this one can be simplified further. So we have D minus 4 and then here you have D squared minus D. Okay. Yang ini adalah T minus 3. Ini sama dengan T minus 3. Ni dengan ni habis. Betul? So you have what? Negatif. Okay, saya tak suka lah ada negatif-negatif ni. Saya faktorkan lah. Macam tu kan? Okay. So ada lagi negatif kat sini. Tak berapa suka. Bukan tak berapa suka. Boleh je. Tapi macam tedious lah nanti kan. Okay. So saya darabkan both side dengan negatif. So I have 3 minus T, 3 minus T. So dapatlah benda ni. Okay. And then you can actually kalau you pecahkan dia akan jadi macam ni lah. Kalau you expand dia akan jadi D squared X plus 4X equals to 3 minus T. Okay, boleh faham? Macam mana dapatkan? Okay, this is non-homogeneous kan? Bila non-homogeneous, you kena hati-hati. When you deal with non-homogeneous, you kena pecahkan pada dua. You kena ada XC dan juga XP, betul?
Betul.
Betul. So yang tadi, yang sebelum ni, we are dealing with homogeneous, but this one is non-homogeneous. So cari XC, cari XC macam biasa lah. You just let the expression on the left hand side ni, the belah kanan jadikan kosong. So you transform into characteristic equation. So you have k squared plus 4 equals to 0, and you solve for k happens to be plus minus 2i. So the roots here are complex root. Okay, we have complex root. Okay, so bila complex root, dia punya kat sini P plus QI kan, P plus minus Q. P dia sama dengan kosong, Q dia sama dengan berapa? 2 kan? So you akan dapat solution you tu XC, the complementary function would be C1 cos 2t plus C2 sin 2t, or it can be the other way around, tak ada masalah. Okay? Alright, so we managed to find the corresponding complementary function. Now we would like to find what the the corresponding particular solution. Okay, so to find the particular solution, so nampak tak the expression f of t ni sama juga dengan apa? This is f of t. Okay, f of t kita bentuk dia adalah 3 tolak t. Okay, so 3 tolak t, f t kita sama dengan 3 tolak t, ataupun nak tuliskan dia sebagai negatif t tambah 3. So this one is a polynomial of degree 1, right? So katalah you want to use the technique of method of undetermined coefficient or the superposition approach. So nak guna teknik tu maknanya you kena guess ataupun you can assume you punya particular solution dulu. So dia akan mengambil bentuk polynomial of degree 1. So you have A plus BT. Just now we use the parameter C1 and C2. So this time you nak guna A, B, C pun boleh, tak ada masalah. Okay, so we have XP being A plus BT. You take the first derivative, you get B, and then the second derivative would be 0. And then what you do is, katalah you name this one as star, you substitute the star into equation number 4 yang ini. Right, masukkan macam biasa. Ni teknik ni kita bukan baru lagi dah you masukkan, and then you compare like terms. Maknanya by comparing the coefficient of the ni, you akan dapat bila t to the power of 0 ataupun constant ni, you akan dapat 4a. 4a sama dengan berapa? 4a sama dengan 3, betul? So a sama dengan 3/4 kan? So dapat ini, and then b, coefficient of the t ni is for b, on the right hand side you have negative 1. So you have, kalau t to the power of 1, okay, so you have 4b equals to negative 1. So b must be what? Negative 1/4. So dapatlah benda ni. Okay? Right. So apa jawapan bagi kita punya XP then? XP sama dengan, we replace the A with 3/4 and the B with negative 1/4. So you have this one. Okay? So the next one is to combine both the complementary solution dengan particular solution. So the complementary solution tadi resulted in C1 cos 2t plus C2 sin 2t, and then this one is the XP. So dapat dah kita punya solution. Okay, solution untuk X lah So macam mana nak selesaikan untuk Y? You boleh pilih equation yang mana you nak pilih tadi. Tadi kita guna equation yang pertama kan. Equation yang kedua. Ikut yang ni mana yang mudah lah. Katalah menggunakan equation yang kedua. Sebab kedua-duanya ada y double prime. Ini y prime. Kita pilih yang sikit lah. Okay. So apa yang saya buat adalah saya guna equation yang ni. Mana-mana boleh. Yang pertama dan kedua. Saya guna yang kedua sebab dia homogeneous. Dan satu lagi untuk y ni dia ada sekali je dia punya derivative. Okay. So nampak tak? Kita tak ada y kat sini, tetapi kita boleh gunakan apa? You can express the y prime as negative X prime minus X. So you dah dapat X tadi, you cari X prime. Okay, so you akan dapat benda ni. So masukkan dekat sini, you akan dapat Y prime. Okay. Saya dah dapat ni. Y prime equals to negative X prime tadi saya dah dapat. Tolak X, dapat benda ni, and then you dah dapat benda ni. Okay, nampak tak? Kita tak ada Y kan? So daripada Y prime, from Y prime, are we able to find the Y? Kan kita ada Y prime, macam mana cari Y? Kita differentiate ke kita integrate?
Integrate.
Integrate. Kenapa kita tak differentiate? Kalau kita differentiate yang ini, dia akan dapat Y double prime, betul? Kita tak nak, kita nak cari Y. That's why saya kata tadi, macam example yang sebelum ni, dia tak ada, dia terus kan kita masukkan nilai X tu boleh terus dapat Y atau boleh terus dapat X. Tapi untuk equation yang tadi tu, dia ada dua-dua macam memerlukan you untuk dapatkan dalam bentuk derivative of Y. Sedangkan you tak tahu Y apa. Okay, so kita pilih equation yang lebih mudah. Yang tadi kita pilih equation yang homogeneous dan dalam masa sama dia punya derivative tu macam kurang sedikit. Tapi nak selesaikan for Y, you just need to perform the integration of the Y prime with respect to T. So you akan dapat benda ni. Okay, so maknanya X kita dah dapat. The general solution ni X kita dah dapat tadi. And then Y ni pun kita dapat daripada mana? Kita dapat daripada sini. Okay. Alright, boleh faham?
Boleh.
Boleh nanti you all tengok balik example ni and try to understand. Dan kadang-kadang dia melibatkan both the derivative and the integration, differentiation and also in the integration depending on the context soalan tu lah ya. Okay, alright. So any other questions? Anyone would like to ask questions regarding this example? Raja Izzah? Raja Nuriza?
Yes, madam.
Okay, ada soalan nak tanya? Boleh faham?
Boleh faham?
Boleh. Alright, good. Okay, now we proceed to the next slide, right? Proceed to the next slide. Okay, yang ini adalah solving the differential equation by systematic elimination, and notice that satu, the equation ada yang non-homogeneous, ini non-homogeneous. Okay, yang ini homogeneous. Lepas tu dia ada apa ni? Initial condition kan, I have initial value problem. Okay, dia ada initial condition whereby the value of X and then Y at T equals to 0 happens to be 0. Guna dia ni adalah untuk cari the value of the parameter. Okay, alright. So yang ini saya rasa macam saya nak explain, sekejap saya explain supaya kita buat daripada bawah, kita start from scratch. Saya ambil soalan ni. Nak copy pun payah nak copy. Okay, saya nak you all buat sama-sama benda ni. Alright, apa kita buat step pertama tadi? What do we do? Okay, dah ready dah? Pen and pencil? Pen and pencil, pencil and paper? Okay, so you have what? Dx plus y. Okay, so here you have 3x plus dy minus 2y. Okay, ni boleh tuliskan sebagai 3x plus d minus 2 y equals to 0. Okay, are you all with me? So kita dapat benda ni. Okay, dekat sini kata solve for y by eliminating dx. Okay, you solve for y by eliminating dx. Solve for y. Okay, kenapa nak eliminate dx ni? Kita tulis baliklah kat sini. Dx plus y equals to equation number 1, equation number 2. Okay, saya nak you all buat sama-sama. Okay, so apa kita buat adalah we multiply the first one dengan 3. Okay, so we have 3dx plus 3y equals to 3e to the power of 2t. Okay, and then the second one we apply the derivative, so we have derivative of equation number 2, so t is just a constant, so we boleh keluarkan ke depan, dx plus okay, alright, so this is equation number 3. Okay, this is equation number 4. Okay, so kita buat apa ni? 3, kita buat apa next? Minus 4 kan? Betul tak? Ini tolak ni dah habis, ini tolak ni jadi apa? 3y minus d squared minus plus 2d sorry, this one should be minus. Tak apalah, saya kembangkan teruslah. Saya kembangkan. 3y tolakkan dengan d kuasa 2. Y tolakkan dengan tolak 2 d y equals to equals to 2t. Okay. So kita akan dapat apa ni? Negatif d kuasa 2y tambah 2 dy tolak 3y sama dengan
tu tambah juga.
Okay.
Yang 3y tu tambah. Yang depan.
Ni tambah kau tambah. Tambah ada lagi? Betul?
Okay.
Alright. So, kita tengok dekat working dia tadi. Kat mana tadi? Kita dapat benda ni kan tadi kan? Alright. So, kalau kita nak biasanya d squared tu dia positif, right? Kita multiply all the terms dengan negatif. So, kita dapat negatif. So, we should be getting kena alihkan dia ni. Tak boleh. Okay, dah kita dapat. So we have square y ataupun kita nak keluarkan saya tak nak tulis y di sini. Saya tak apalah, saya buatlah balik semula. Takut you're confused. Minus 2 dy minus 3y. Okay. So ini boleh faktorkan. We have d squared minus 2d minus 3, put everything in a bracket. Y equals to negative 3e 2t. Macam tu. Okay. Right. Are you all with me? Semua dapat macam ni?
Dapat doktor.
Dapat.
Alright. Okay. So kita dapat benda ni. Ini saya terangkan yang tu lah. Macam biasa. Again, this is a non-homogeneous kan. Non-homogeneous equation maknanya you kena cari dua benda lah. Okay, let me just enlarge this one. Alright, so the first part is finding the XC or the complementary solution, right? And then you dapat benda ni, you convert into the corresponding characteristic equation and then you factor out. It turns out that K equals to -1 or 3. Okay, so this is the solution that you have lah with respect to the particular with respect to the complementary solution. Since the equation is in terms of y kan, maknanya jawapannya adalah y dahulu. Okay, now you want to find the XP pula kan. This time around, I'll be using the annihilator approach. Untuk selesaikan ini guna annihilator approach, saya kena pastikan yang ni saya boleh tukarkan kepada homogeneous. So maknanya e to the power of 2t. Hopefully you still fresh mengenai annihilator ni. Nampak tak alpha dia sama dengan 2, so the corresponding annihilator would be d minus alpha. So d minus 2 would be the annihilator for -3 e to the power of 2, 3. Okay, alright. So apa ni saya buat adalah I apply the same annihilator ni on both side of the equation. Right, on both side of the equation ni saya merahkan. Right, ini pun saya apply the annihilator, but the good thing about the annihilator is that it managed to turn the -3e to the power of 2t tu into 0, right? Yang belah kanan ni because of the annihilator dia akan jadi kosong. Ini ada tambah satu lagi. So selepas tu kita buat apa? Selepas tu kita cari dia punya corresponding characteristic equation. K adalah -1, 3n. So dapatlah yang ini. Solution ada 3 sebutan. Nak cari YP, notice that kita kena eliminate the term that have already appeared in YC, which is this one dengan yang ni dah ada dah dalam YC. Okay, so maknanya YP kita adalah yang ni saja. Tinggal yang ini. So this is going to be our YP. So dah dapat dah kita punya YP. Okay. Ni dah dapat dia punya YP. So sekarang ni kita dah tahu YP. Nak tahu kita punya C3 tu sama apa nilai dia, you find the YP prime ataupun DYP ataupun YP double prime, and then you substitute the function into equation number 5. Kan equation number 5 tadi. Equation number 5 ni homogeneous tu kan, kita dah biasa buat ni annihilator ni, masukkan dekat sini sebab apa? Sebab kita nak cari apa nilai bagi C3. So C3 turns out to be ni equation number 5 tadi. Okay, and then you solve for C3 dapatlah -1. So gantikanlah dekat C3 ni dapat -1. So dapatlah dia punya differential equation. Yang ini adalah kita punya YC, this is our YP kan. Dah dapat Y, nak dapatkan X, pilihlah equation yang sesuai. Saya pilih equation number 2 satu sebab dia homogeneous, senang sikit nak ni, tak tedious. Satu lagi dia dah ada X kat sini, boleh tukarkan, rearrange the term so that X ni jadi tajuk lah. So you bring these two over to the other side, so bahagikan dengan 3, dapatlah benda ni. Okay, and then you just tadi dah cari kan Y, and then you cari Y prime apa dia, dy dia apa, dy sama dengan apa. Okay, masukkan dalam sini and then simplify, so dapatlah jawapan dia X. Okay, alright, ada soalan nak tanya, boleh faham? Senang. So kaedah dia sama ada, you just need to be very careful, particularly when you deal with the non-homogeneous differential equation. Make sure you need to consider both the XC or YC dengan XP ataupun YP lah. Kalau semua homogeneous tak ada masalah, buat sekali dah siap. Tapi kalau non-homogeneous, you need to be very careful. Okay. Alright, so I guess that's all for today. Alright, I leave you with this exercise. You may want to try this one and we'll discuss nanti saya tanya siapa-siapa untuk kita punya kelas besok. Okay, boleh? Okay, ada soalan tanya?
So far tak ada.
So far tak ada? Syafiqah?
Tak ada.
Itu Syafiqah, ada tak?
Ada.
Ada?
Tak ada soalan.
Ada soalan ke tak ada soalan?
Tak ada.
Tahu orangnya ada. Salma? Saja nak dengar suara you all ni. Salma? Salma ada ke? Ke dah pergi masak?
Salma dia pergi tandas.
Oh, pergi tandas. Nasib baik ada orang tolong jawab. Ni satu bilik ke apa ni? Satu hostel Okay, alright. So I guess that's all that's all for today's session, right? So I want you to try out this problem. Ada 3 je. And then the first one is an IVP problem, meaning that you got to find specifically the value of x 0 dengan y0. Tadi initial value problem ke tadi? Aku tak ingat. Kejap. Example ni tadi. Oh, adalah. So maknanya kena cari apa tu? Dia kena selesaikan untuk apa dia C1, C2. Nilai C1 dan C2 ni kena selesaikan actually. Okay. Alright. Kalau tak ada apa-apa, kita berhenti dulu sini. Assalamualaikum. Thank you everyone.
Waalaikumsalam. Thank you.
Salam. Thank you, Doktor.
Alright.
Salam. Terus.
Doktor.